And so on, this is what it does. This is what the wind field does, the wind stress. It's shown here in a piece of a cake. This is your Southern Ocean. Okay, and you cut the ocean, you cut that cake open, you get a slice of this cake, and you can see open up the structure of the layers that you have. Okay, and you can see North Atlantic deep water is coming here from the north, crosses the equator in the Atlantic Ocean, and in the Southern Ocean, this deep water is brought, sucked up to the surface. It ends up, this is the biggest, most obvious upwelling region that we have in the ocean. There's only one problem with this upwelling, is that it has very poor ion contents, so it doesn't stimulate much plankton blooms, but a little bit it does. Okay. Anyway, okay, that's this one. Also, what's inferred here is actually the downward pumping, and this is the intermediate water. This one is pumped in the zone which is known as a convergence zone. Okay, you can see Antarctic convergence, and you can see one zone which is called Antarctic divergence. What it also does, it actually creates something we call fronts. Fronts in the open ocean, which are regions. Fronts are features where the water mass properties change significantly as you move across the frontal zone. Okay, and this, in general, we have three different fronts: polar front, subantarctic front, and subtropical. Okay, let's have a look at a similar sketch. Okay, just see what you find here. This is another sketch that you can find. I think this is from Tomczyk and Godfrey. Here, Antarctica is the South Pole is on the left side. Okay, equator is on the right, and again you can see the structure. Upwelling of deep water at around 60 degrees south. You get the formation of bottom water. We talk about that, or probably we already have talked about it, but focus on that later on again. Okay, and indeed you get the downward pumping of intermediate. And then as you go closer to the equator, you have that warm water pool which controls the density stratification. Okay, that's fascinating, isn't it? Okay, so what this mechanism of Ekman downward pumping is also called subduction, oceanic subduction in some books. Okay, that you learn a new word. It's not to do with tectonic plates here in this example. It's about the subduction of layers of water masses. Okay.